Welcome to video number 1 here of our series of videos to kind of talk about the binomial theorem. In these first set of videos, I want to recap and summarize the tasks that you all did on Tuesday and or Wednesday, depending on when I saw you. I had students pair up and I gave you a specific task to do. What I want to do with this first sheet is summarize those 4 tasks and kind of see how they're linked together, because it turns out you all were doing the same thing. And all of that is going to lead to support our work with the binomial theorem. So if you want a big idea, this is the big idea. We're talking about the binomial theorem. What it is, we're going to get to here in the next couple of videos. But what I need you to do is grab a blank sheet of paper, and on that paper, either by folding or I guess by eyeballing, we're going to break it into 4 squares. So a clean sheet of paper, we're going to partition into 4 squares. Each square is going to we're going to put information about each of the 4 tasks that you were in charge of. So we'll label it like so. And with each of these videos, we're going to summarize what that particular task was about. I'm actually going to save task 1 till the very end, and I'm going to start with task 2. So if I could zoom in here, I would zoom into task 2 to tell us what we want. But because I can't, I'm just going to write it here, and you are copying it into the top right box there. So again, clean sheet of paper, either in your head, break it up into 4 pieces, or manually fold it twice so that you can get 4, I guess, rectangles, right, partitioned by that fold. And then this is what you're going to put in under the task 2 thing. So people that did task 2 were counting how many ways can 4 coins be tossed. And so if you think about it, if you toss 4 coins, the first toss could yield a heads, the second toss maybe a tails, the third toss a tails, and maybe the last toss a heads. So this is one way we can get 4 coins to be tossed. Or I could get very lucky and have them all be heads. Or I could be lucky and have them all be tails. Or I could have 2 heads at the beginning, but then tails at the end. Or do you see how many different combinations we have? So it turns out there are a total of 16 different ways. And the people that had this task were asked a question. And the question was, out of these 16 ways, how many produced 0 H's in the pattern? So I'm going to go ahead and try to finish some of these. So let's say I have one head and 3 tails. Or I can have a tail, head, tail, tail. I could have a tail, tail, head, tail. Or I can have tail, 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 head. Or I could have tail, head, 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 tail, head, 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 tail, head, 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 tail. Or I could have, and so as you can see, there's a lot of different ways, right? So what was the question? Well, the question was, out of these ways, how many ways were there 0 heads? 0 H's. Well, there was only one way. And then the question was, how many ways is there only 1 H? Well, that'd be 1, 2, 3, 4. So 4 different ways. And how many ways were there only 2 heads? So whoever was doing this task, this was a very straightforward task where you did the experiment and then you just kind of ran the results, right? The experiment wasn't even an actual experiment because we were just writing down how many different possibilities. Once you wrote all 16 down, out of those 16, there's only one of them that has 0 H's, and that's the one I circled. There are 4 of them that have 1 H. There are actually 6 that have 2 H's. How many ways can we get 3 H's that would be 4. And then how many ways can we get 4 h's? And there's only one way to do that. And so people that did this task, they got these numbers 1, 4, 6, 4, 1. What were those numbers answering? How many ways, if you flip 4 coins, how many ways can I get 0 heads showing? Well, that would be yes. Okay, that's what task 2 was about. It was just thinking of the possibilities, and then out of those possibilities, doing some investigation of that. Now, there were 16 ways to do that because there were 4. If you had more than 4, well, then there's more ways to do it. So just so you know, if there were 5 coins, there would be 32 ways to do it. If there were 6 coins, there would be 64 ways to lay that out. And so as you look at this, every coin that I add to my flipping experiment, the number of ways to write them out increases by a factor of 2, right? I multiply by 2, and that's how many different ways. So there's a pattern there, and in a little bit, we're going to come back to this blue part, and we'll see that there's a pattern there as well. This is all I need you to write for task 2. We'll come back in the next video, and we'll talk about task number 3.